Okay, today we're going to be talking about what seems to be an unrelated collection of topics. But as we go on, we'll see that in fact they're intricately linked with one another. So we're going to start by talking about the assignment operator and objects. Then we're going to talk about a topic known as aliasing or aliases. And then we're going to end with a discussion of memory equality versus state equality. Okay, so talking about the assignment operator, this is probably the first operator we encountered, and it's just the equal sign, nothing special. The equal sign, the assignment operator, copies the value on the right-hand side into the memory location on the left-hand side, okay? And that functionality does not change whether you're working with primitives or objects. It copies the value on the right-hand side into the memory location on the left-hand side. So what I want to do is look at some code with primitives and then look at the same code with objects. And we're going to see how does the assignment operator change. It's not even the assignment operator changing. How does the impact of the assignment operator change when we're working with primitives versus objects? We'll say it that way. Okay, so I'm going to write some code here, and we're going to begin by looking at integer variables. So let's say that we had an integer named num1, and I'm going to set that equal to 20. Then I'm going to create a second integer variable num2, and I'm going to set that equal to num1. And then I'm going to change the value of num1 to 80. And my question to you is, after executing these lines of code, if I was to print out the value of num2, what value would be printed to the console? Okay, so I want you to pause this video and look at this chunk of code and make a prediction. What do you think is going to print when we print the value of num2? Okay, so before I tell you the answer, I think there's two reasonable thoughts. The first is that if we were to execute this code, the number 20 would print to the console. And that's because when we created num2, we initialized it to num1. At that point in time, num1 held the value 20. The second reasonable thought is that if we were to execute this code, the number 80 would print, right? Because we've set num2 and num1 equal to each other, and then we change num1 to 80, and if they're equal to each other, then num2 should also reflect the value 80. Okay, so that's the other thing you might think. Okay, so if we were to actually execute this, the value that would print is 20. Okay, so that is the value that's going to print. So we're going to draw out memory, and we're going to look at this code in terms of what's happening in memory to convince ourselves that indeed 20 would print to the screen. Okay, but before we do that, I want to run the same experiment, but instead of using primitives, I want to use objects. So today we're going to look at a new class. We've seen the string class, scanner, random, and today we're going to look at the die class. And this is a class I wrote myself, and an object of type die represents a die. Okay, so that's kind of what I'm showing here. So I wrote a Java class that simulates the functionality of a die. Okay, so this is a 6-sided die. When you roll the die and it tumbles and then it stops, and whatever that number is on top, that's what's known as the face value. Okay, so in this picture, the face value of this die is 3. So here is the documentation for my class. And this class represents a single n-sided die. The top number of the die is called the face value. And I've created basically 2 ways to change the face value. You can either roll the die, and I have some code that simulates a random roll of the die, or you can explicitly set the die to a particular face value. Okay, so that's kind of the equivalent of just like picking up the die and like setting it to 3 or 2 or whatever. Here are the constructors. So if you call the constructor that takes no inputs, that's known as a default constructor, that will return back a 6-sided die. Or you can call the constructor and pass in the number of sides, and then it will create a new die with that number of sides. You've got an option. Here are the methods that I added to my die class. So here's the roll method. So if you call this method, it will simulate a random roll of the die. And then I'm returning back to you the new face value. You can call get face value. If you call this method, it returns back the current face value of the die. Contrast that with its opposite, set face value. So this one, oops, if you call set face value, you pass in an integer. And this is how you can explicitly set the die to whatever value you want. Last but not least, we have an equals method. So we saw the string class also has an equals method, and I've added an equals method to my class. So if you were to call equals, you would pass in another die. And this method is going to return true if this die and the other die that you passed in have the same number of sides and the same face value. Okay. And I just made that up. To me, it seems like, you know, what makes two die equal? They have the same number of sides and the same face value. And if you change one of those pieces of information, then they're not really this like equal anymore. So that was me sitting down thinking about what makes two die equal. Similarly, I have this toString method, and the toString method returns back a string. So you'll see the return type here is string. And this string summarizes the state of the die. Now, in the past video, when we talked about objects, I talked about the state of an object. And again, for this class, the state of a die is the number of sides and the face value. So if you call toString, it will return back a string that has the number of sides of the die and it has the current face value. Okay. Okay, that's basically it. That's my class. I wrote it myself. It's super simple. And so let's go ahead and repeat this experiment here, but now we're going to repeat it with objects, with die instead of integers. Okay, so I'm going to create a new die D1 equals new die. This is going to create a new 6-sided die. And let's assume that it starts off with a face value of 1. Okay, now just like we did on the left, I'm going to create a second die. So die D2 equals, equals D1. So just like I did on the left with the integers, I'm going to create a second die, and I'm going to set it equal to the first die. Then I'm going to change the first die. So I'm going to say D1 dot set face value and let's set it to 4. So my question then is the same. If I was to print out the face value of D2, what would print? Get face value. So remember that the get face value method returns an integer, which is the face value, and I'm going to print that. So the question is, if we were to print this, what is the face value for die 2? Is it going to be 1 or is it going to be 4? Okay, now I'm not actually going to answer that question now. We're going to look at memory and we're going to execute both of these pieces of code, see what happens in memory, and see if we can answer the question that way. Okay. Okay, so I'm going to step through this code and we're going to execute it and see what happens. So we begin at the beginning. So let's create a variable num1. We will initialize it to the value 20. We then create a new variable num2. I'm initializing it to whatever value is stored here in num1. And that value, if we look it up, is 20. Then I say num1 equals 80, so that's going to overwrite this value here, and it's going to be 80. Thus, when we print out num2, we'll see it is still 20. In particular, there are two different 20s running around. When we said num2 equals num1, it copied the value here and it stored it in num2. So it copied the 20 and it stored it down there. At that point in time, we have two 20s. One of them is stored in num1, one of them is stored in num2. Okay, so we can change num1. That change is not reflected in num2 because they really are storing two different values. Okay, let's do the same thing with our objects now. So we create a new object D1. Okay. On the right-hand side, we're going to create a die object. It has 6 sides, and we said it started off with the face value of 1. And then we're going to store this memory address up here in D1. That's what it means to be a reference variable. Okay, so D1 is pointing to this object by storing the memory address 1200. Okay, next line of code, we're going to create a new die, D2. And we're going to use the assignment operator to set them equal. Again, the assignment operator does the same thing. It's going to copy the value found in D1, and it's going to store that in D2. So the value stored in D1 is the memory address 1200, and we're going to copy that down here into D2. So the assignment operator has done exactly the same thing in both cases. It took the value that it found, it copied it, and it stored it in the memory location on the left-hand side. Just as we have two 20s, we also have two memory addresses. Okay? All right, now when I say d1.setFaceValue, right, d1 is a memory address, so that's going to jump us down here. The dot operator allows us to call a method within the object. Oh, we're calling the method setFaceValue, and we're setting it to 4. Okay, so let's do this in red so it's kind of clear. So now we are setting it to 4. Okay, so if we were then to print system.out.print, and we would print the face value of D2, what would it be? You can pause the video at this point or not, whatever you need, okay? Okay, so if we were to print D2, or print its face value, we would find that its face value is 4. Okay, so by changing the face value of die 1, I have in fact changed the face value of die 2 as well. And that is because die 1 and die 2 both point to the same object. They are both storing the same memory address. So if I change that object by calling set face value on die 1, it's going to be reflected in die 2 because they are in fact the same die, okay? So I guess 2 observations I want to make here. The first is that the assignment operator is doing the same thing in both cases. It is copying the value on the right-hand side into the memory location on the left-hand side. However, those values are different. For primitive variables, the value is a literal number. So when we copy it, they no longer interact with each other. I've got two 20s floating around. But for reference variables, that value is a memory address. So even though I've copied it and I have 2 copies of the memory address, I only have 1 object, and they are both pointing to the same object. So this is something that is known as aliasing or aliases. Okay, so when 2 reference variables refer to the same object, in other words, when 2 reference variables store the same memory address, they are known as aliases of one another. Okay, and this kind of is the same usage in English. Like if you have a spy and that spy has different passports, and in one passport it's name 1 and another passport it's name 2, whatever, right? Although there's 2 different names, it's the same human being. It's the same person. And so we say that those are aliases of one another. In the same way, when we have 2 reference variables that hold the same memory address, they are aliases of one another, okay? And in that case, you can change the object using any of its aliases. Okay, we might have 3 or 4 or 5 reference variables all holding the same memory address. You can use any of those reference variables to change the object. That change is going to be reflected in all of the aliases, right? So if I use die3 and I change the face value, that's going to show up if I call d1.getFaceValue or d2.getFaceValue, right? They're all aliases pointing to the same object. So this is one of the most important things. This is also related to, we talked about pass by value versus pass by reference. And this is basically just the same phenomenon, just looking at it slightly different, right? So when we call a method and we pass in a primitive, right, the assignment operator is taking a copy of the actual argument and it's storing it inside of the formal parameter. And if that's a primitive, then that copy means inside the method, I can change the formal parameter, and that's not really reflected in my original variable. But that's not the case for objects. So for objects, I'm passing in, I am making a copy, but it's a copy of the memory address. So I'm taking the memory address and the actual argument and storing it in the formal parameter. Thus, in the method, if I change the object, that is going to be reflected in the original method. Okay, so this is basically the same thing, but just kind of recast a little differently. Okay. Wow, that is aliasing. And why are we even talking about this? Okay, memory equality versus state equality. So this is kind of what I've been building up to in this lecture. And that is when you have primitives, there's one and only one way to check for equality. Are these two values the same? That is using the equality operator, equals equals or not equals. That's it. There's no other question to ask. Is 2 equal to 2? Yes, it is. Is 2 not equal to 3? No, it's not, okay? But when we talk about objects, all of a sudden there are 2 different ways to ask, are these objects the same? I guess if we have reference variables, there are 2 different ways to ask, are these reference variables the same? One of those is memory equality and the other is state equality. And we're going to look at both of those. So right here, this is me just rehashing what equals equals and dot equals do. They check if 2 values are the same or if 2 values are different. That does not change whether we have a primitive variable or a reference variable. But what does change is for reference variables, because they're storing memory addresses, when you use equal equals, you're asking, are these 2 memory addresses the same? Are these 2 reference variables storing the same memory address? Okay, so this is a typo here. It really should be for reference variables. Reference variables and objects are so intricately related that sometimes I think I personally use them interchangeably when they're not. They really are 2 distinct concepts. So for reference variables, okay, this, meaning the equality operator, is checking for what's known as memory equality. Are these variables aliases of one another? Are they holding the same memory address? The end. Going back to our die example, if we wanted to have 2 reference variables of type die that are equal in terms of memory, the memory address they store, we could use the same code that we had before, right? We could say die d1 equals new die. And then I could say die d2 equals d1. This is one way to accomplish memory equality. They are now storing the same memory address. Okay, sometimes though, we are not interested in memory equality. I don't want to know if these 2 variables are pointing to the same object. What I want to know is these 2 variables, the object they're pointing to, does it have the same state? Okay, so sometimes I have 2 die and I want to know, are those die the same? Do they have the same number of sides and do they have the same face value? That's another way of asking about equality when it comes to objects. Strings. Sometimes I want to know, are these two strings like literally the same sequence of characters? T, A, C, O, M, A. They could be two strings, but if each of those strings has exactly the same sequence of characters, then they have the same state, right? They are equal in terms of state. And oftentimes that's the question we want to ask. Okay, so oftentimes I don't want to know in terms of memory, I want to know in terms of state, are these two objects equal? Okay, one way we could get two die that have the same state is I could say die D1 equals new die. D1 dot set face value. And let's set it to 5. And then I could say die D2 equals new die. And I could set it also to 5. Okay, so set face value to 5. So here are two die, and they have the same state. They both have 6 sides, and they both have a face value of 5. In this case, in terms of state equality, they are equal. So when we want to check state equality, not memory equality, but state equality, the way that we do that is we use the equals method. You saw that the string class has an equals method. Also, my die class has an equals method. That's not a coincidence. In every class that you can call, the scanner class, the random class, string class, die class, and every class you will write, there is something known as the equals method. And the equals method is how you check for state equality. Okay, so going back to the documentation for my class, right, the equals method, oh, it's all the way down here. Here. Right, this is a method that is provided by every class. If you write your own class, you need to provide it, and we'll talk about that. And basically what it does is it takes in another object and it checks if they have the same state. That changes depending upon what the object is. For die, state is represented by the number of sides and the face value. For string, state is represented by a sequence of characters. Okay, so the equals method is something that is in every class, and that is how you can check for state equality. Okay, so keep it simple, primitive variables, you have only one way to check for equality, equals equals, but reference variables, you have two ways. You may ask about memory equality, you may ask about state equality. For memory equality, you use equals equals. For state equality, you'll use dot equals. Okay, having belabored that point, we're gonna end with an exercise here. So I have written a main method, and in this main method, what I want you to do, so here's some code. I just dumped some code in here. Look, I'm creating a die, and then I create a second die. So the question is, how can you write code here or modify this code to get all 4 possible print statements to execute? Okay, so you will write some code, set the die equal to each other all you want, change their face values, do what you need to do. And then down here, I'm using memory equality, I'm using equals equals. So if die1 equals equals die2, it will print yes, they are equal according to equals equals. Else it will print no, they are not equal according to equals equals. I then use the equals operator, so this is state equality. So I'm calling die1 dot equals die2. That returns a Boolean true or false, and I'm storing that in my local variable. If my local variable holds true, then I'll print yes, they are equal according to the equals method. Else I will print no, they are not equal according to the equals method. So the question is, what code can you write, or how can you modify this code in order to get all 4 possible print statements to print out? Okay, yes, they are equal according to equals equals, and yes, they are equal according to the dot equals method. Okay, so that's one possible output. Or yes, they're equal according to equals equal, but no, they're not equal according to the equals method. That's the second possible output. Okay, so these are the 4 outputs that you could get. Okay, so I want you to pause this video. For each of the 4 possible outputs, which I'm showing here, write code, modify code. How can you trigger that output? Okay, how can you trigger this program to print in each of these 4 different cases? Okay. Now let's just do the first one together because we kind of already answered this one and there's not much there. So if I wanted this program to print yes and yes, so yes, they're equal according to equals equals, and yes, they are equal according to the equals method, we kind of already saw how we could do that. We could just say die d1 equals new die d2 equals die1. At that point, we don't even have to do anything, we're done. Okay, so they are equal according to memory equality because they are storing the same memory address, so this will print yes. They are also the same object, right? They're just aliases, so the equals method will also return true, and that will print yes. Okay, so if you wanted to get yes and yes, we kind of already answered that, so maybe jump and think about 2, 3, and 4. Okay, okay, pause the video. How could you write code or modify this code to trigger each of those outputs? And then we'll talk about that when you unpause the video. Okay. Okay, so let's go through and talk about, okay, hold on, let me think about this. Do I want to do this in the video? Might as well, okay. Okay, so let's start at the bottom. So no and no. If you wanted no and no, you could create 2 different objects. So I'd have to say die d2 equals new die, and then just set them to different face values. 4 die2 dot set face value 1. Now they are not equal in terms of memory equality because I created 2 distinct die with their own lovely memory addresses. So they are not holding the same memory address. Also, they have different face values. So if I was called dot equals, it would return false. Okay, so that's how we could get no and no. No and yes. Okay, so no, they are not equal in terms of memory equality. Yes, they are equal in terms of state equality. That's almost identical in terms of this code. All I have to do is this. So here they are 2 distinct die. So they are not equal in terms of memory equality, but I set them to the same face value. So they are equal in terms of state equality. These are 2 6-sided die, and they both have a value of 4 because I made them have a value of 4. Okay, last but not least, yes and no, this is impossible. Okay, there is no way that you can have 2 reference variables that hold the same memory address, so they're pointing to the same object, but when I called dot equals, it returns false. If they are pointing to the same object, then the dot equals method had better return true, right? Because a die, when compared to itself, should have the exact same state. Okay, so this one is in fact impossible to accomplish. Okay. Okay, so if there's anything there that surprised you, then you can go back and listen to my explanation, or you could make that one of your questions for the week. And let's just do a quick recap because the purpose of this lecture may have gotten lost in all the details. So high level, the assignment operator always does the same thing. However, what that thing is has different implications when you're working with primitive versus objects. And we saw that here in our diagram of memory. It really is doing the same thing. There are 2 20s and 2 memory addresses. But what that means is there's only one object. Both of these variables are pointing to the same object, thus they are aliases of one another. Then in terms of equality, again for primitive, there's only one way to ask, are these 2 primitive values equal? That is equals equals. With objects, we have 2 different ways. We may ask, are the memory addresses they're storing equal? Or we can ask, are the objects they're pointing to equal? Those are 2 different questions. In the former case, you would use equals equals. In the latter case, you would call the equals method. The equals method will be in every class you ever write. It is a standard method that is always provided. Last but not least, we looked at this code and we stretched our brain a little bit and tried to figure out, could we get each of these 4 possibilities to execute? And we saw in most cases we could, just by finagling and changing things, except for here. Okay, and this one was impossible. Okay, that is that, and we're done.